Hey guys, how's it going? Fred here at Math and Engineering. We are going to get into a super important topic, all right? This is the start of what's going to be the rest of your calculus career in university probably, because after this step, when you go into Calculus 2 and then Calculus 3, it's almost entirely integration, almost completely integrals, 100%. So antiderivatives essentially are integrals. Okay, and it's the beginning of what we call indefinite integrals, okay? So an integral in which you don't evaluate it on a certain bounds. You just evaluate it generally. So we'll get into more of that later. That will make sense to you at a later date. But for now, let's just talk about antiderivatives, okay? So antiderivatives are self-explanatory. They're the reverse of a derivative. So for example, if I know that the derivative of ln x, so if I say d by dx of ln x, okay, is equal to 1 over x, right? The antiderivative of 1 over x, so if I say, and I'll just use the integral sign because it's the same thing, the antiderivative of 1 over x, okay, will equal ln x, okay? So we're just going, when we do the derivative, taking the antiderivative, we just go backwards from what we did with the derivative, okay? So there are a few rules that you need to remember for antiderivatives, and it's important to remember them now because you're going to use them all throughout integration, and when integration gets a lot harder, which it does, you're going to need to know these like the back of your hand. So we're going to go through the rules that we're using in these three problems. I'm not going to go over all the rules because you can just look in your book for that, and when you do more practice problems after this, you're going to have to use all of those rules over and over again. But for now, I'm going to show you a few rules and a few tricks of doing antiderivatives, and we'll start from there. All right, so let's look at the first question, and find the antiderivatives is referring to all three of these questions. So we have f of x is equal to 3 times root x minus 2 times the third root of x. So when we see a question like this, what we want to do is see these roots in this third root here. We want to put those to the power of, okay? That's going to help us solve this. So we have 3 times x to the power of 1/3, okay? So we have 3 times x to the power of 1/2 minus 2 times x to the power of 1/3, okay? And let me just block this off, this little box here, because I want to show you a rule here. This is called the power rule in antiderivatives, and this is an important one, okay? So I'm going to use the integral sign here, and we'll say that the integration, okay, of a function, okay, dx, this is just a notation, don't worry about that too much, we'll explain that in a later video. Okay, so the antiderivative of a function, okay, we can say will be x to the n plus 1 over n plus 1. Okay, so what that means is if we have a function here, like a polynomial function to a power of a constant, okay, how we're going to find the antiderivative of that is we're just going to add 1 to the power, and then whatever we get from that addition, we're going to take that and divide the whole variable and the constant by that number, okay? So let me do one and you'll just get it right away. It's not too hard. So right now, okay, we're going to evaluate the first term. So we have 3, all right, and we're going to add 1 to this exponent here, okay? So we have 1/2 plus 1, which is 2 over 2, okay? So that's going to give us 3 over 2, and we're going to divide this whole term by 3 over 2. Perfect, let's do the second one, okay? And I'm not going to write this part, I'll just do it in my head. So we have minus 2, okay, times x, all right, and 1 over 3, we're going to add 1 to that, okay? So that's going to be 4 over 3, and we're going to divide the whole thing by 4 over 3. So that's simple, right? That's the first kind of step in doing integrations and antiderivatives. That's what we just learned right there, no problem. All right, so let's go ahead and let's simplify that a little more, okay? So we're going to multiply, the top and bottom by 3 over 2, right? To try and simplify this a little bit more, okay? So that is going to give us, okay? We have 6 over 3x to the 3 over 2 minus 6 over 4x to the 4 over 3, okay? And if we just simplify that a little bit, we divide, for example, these two, we are going to end up with 2x to the 3 over 2 minus 3 over 2x to the 4 over 3. Okay? And let me just write that again. We're going to give that a big f of x, okay? Because that's how we're going to show that we just found the antiderivative. Okay, so we're done that question. And also, don't forget to add this c here, okay? So what this c means, okay, that's called the constant of integration. And we'll get into the meaning of what that is a little bit in the future. For now, just know that whenever we find an antiderivative like this, we're going to add a c. Essentially what that means is that there was some constant there when we drove the equation, okay, that was removed. And now we're taking that constant and we're putting it back in. Just think of it like that for now. Don't worry too much about it, but don't forget it either, okay? When you're asked for the antiderivative, you have to put that c on the end. Okay, it'll make more sense in the future. So let's take a look at the second question. Okay, we have f of x is equal to x times e to the 2. Okay, and I just wanted to show you this question. It's really quick. It's only going to take like 30 seconds. But there's a little bit of a trick here, okay? And the trick is that we have e to the 2. And a lot of people might get confused and think, oh, I have a product of two functions, and how do I solve this? This is, I haven't learned this yet. And always remember that e is just a number, okay? E is a number, and e to the power of a number, or a constant, is another number, okay? So with that being said, we can, whenever we're doing antiderivatives and we have a constant, what we can do is we can just take it to the outside and work on the variable. So we're going to do that, all right? So let's come down here, and we have f of x, okay, is equal to, and we're going to take that e to the 2 out and just work on the x on the inside, okay? So now let's take the antiderivative of x, okay? And we're going to apply this power rule up here, and the x to the n plus 1 over n plus 1, same one. So this is x to the 1, so we're going to add 1 plus 1, and that's going to be 2, okay? So f of x is equal to, take that constant, move it outside, okay? And we have x to the 2, and then we're just going to divide by n plus 1, which is 2. We are going to add our c, right? Because that's what we do when we take antiderivatives. All right, and that's the second question finished. So, like I said, really quick, really simple. Watch for those constants, okay? That's how we work with a constant. The third question is a little bit trickier. So we have f of x is equal to 2 plus x squared over 1 plus x squared, okay? So this is one of those tricks in which you have to add and subtract to the fraction in order to make it more simple. And professors love to do this kind of stuff on exams because it really throws people off and it brings the average down. But what we can do here, if you'll notice, is we can split this 2 up into 1 plus 1. Oh, what does that do? Well, that allows us to break it up into two fractions, which are much easier to solve, okay? So let's go ahead and start with that. Always, if you're given something like this on the exam, look for that. See if you can take the constant and turn it into perhaps the sum of two different numbers, and see if that helps you break it up into two simplifiable fractions, okay? So if we take this and we turn it into 1 plus x squared over 1 plus x, which is squared, which is the same thing, right? And we separate this part and this part here. Now, as you can see, we rewrite it in this way. We are left with two functions that we can easily find the antiderivative of, and I'll show you why. Is up in the top here, I want to show you something. So if we find the integration, which essentially is the antiderivative of tan inverse, right? And you'll remember this from when we did the derivatives. The integration, okay, of 1 plus x squared, or the antiderivative, essentially, of 1 plus x squared is equal to tan inverse of x. This is a really popular one for tests for some reason. Plus c. The professors really love to throw this in there. At least they did when we took the course. So keep that in pink for you. All right, so knowing that, and you remember the derivative of tan inverse x was just 1 over 1 plus x squared, okay? So the reverse of that is the antiderivative, right? That makes sense intuitively. And that's just something that you're gonna have to remember and you're gonna have to recognize. So, and if you look down here, that's what we have. We have 1 over 1 plus x squared, okay? So we were able to create this quotient here by manipulating the numerator. So let's find the antiderivative now. We'll take the big f of x, okay, and Antiderivative of this, like we just said, is tan inverse. And this is going to cancel here, right? That's just going to become 1. And the antiderivative of a constant is x. So if you remember, the derivative of x was 1, all right? And the antiderivative of 1 is x, okay? So this is just going to be x, all right? And we're going to add our c at the end. Perfect. So I hope these questions kind of started to familiarize you with what antiderivatives are and mainly how to solve antiderivatives, because your professor will go over this stuff and the theory. What we want to focus on is like doing the problems and looking for tricks. That's what we're all about. So thanks for watching. We'll do a few more antiderivative questions in another video as practice, and we'll do trickier ones. So stay tuned for that. Thanks for watching, guys.